Hi, welcome to the session of Observability 2.0, much more than just logs, metrics, and traces. Hi, this is Neel Shah, a DevOps community guy. I work as a developer advocate and middleware, and I also co-organize a lot of communities around DevOps in my local region, like Google Cloud, CNCF, HashiCorp, and others. More than 15 plus hackathons and have given talks in 10 plus conferences, including PlatformCon, KCD, KubeCon, Linux Fairs. So coming to our today's agenda is Open Elementary's role, reducing downtime with auto collector, now apps in observability, optimizing observability cost, AI-driven futures, and takeaways. So seeing the evolution of observability around 2015, people were also using the modern applications. So they were using tools like using Grafana, and then it came the era of telemetry explosion. A lot of data coming out from application, infra, and things, and there are a lot of chaos or leaks of data. So it created a scenario where a lot of data is there, but it becomes very challenging to tackle that. And yeah, around 2030, 2023, the era of AI came, and people are using AI to improve their observing spectrum. Some from firefighting to force it. Imagine a scenario where it's 2 a.m., your application production is down, and there are tons of data flooding out, and you don't do actually what you need to dig in. And it takes a lot of manual effort for that to understand the problem. And meanwhile, there is downtime. It also affects the business scale. Now, imagine a better world where observatory system data software anomalies early. You have AI flag, the growing risk before any outrages. You act proactively, avoiding the incident altogether. From firefighting to force save by Observer 2.0, from we have shifted from reactive to predictive. Just like this. We don't want manual troubleshooting. We want auto explain incidents so that we don't need to hurry at the last time and do a lot of things manually. Next comes the enhanced capabilities. There are correlation and contextualization. So there is automatic data correlation from front end to back end. There is AI redirection. There is accelerated root cause because coming with a lot of automation of AI, we have refined a lot of things that helps us to understand and have a better root cause. In today's journey of the 2.0, we have we're covering the evolution of the actually we will cover the rise of open telemetry, ML, LLM observability, erasing downtime with code and collector. We will understand how the order connector works. We will also see the cutting costs with smarter ingestion, and that will be AI-driven future observability. So here's the evaluation authority. There are a lot of siloed data sources. Siloed means there are a bunch of data. We don't know actually what to do that with that. We are performing manual root cause analysis all of time. We have growing telemetry volume leading to higher causing complexities. Then comes the evolution of the unified telemetry with open telemetry. It comes with proactive anomaly reduction, with predictive insights, and post-optimized data pipelines. Then it came the rise of OpenTelemetry. Before OpenTelemetry, the thing was people were using and collecting a lot of data, but it was in different formats. So if a person A wants to share their data with person B, it was not compatible, and it was creating a lot of chaos. Then the rise of OpenTelemetry came, which created a vendor open source framework for collecting telemetry data. Next is rise of OpenTelemetry. OpenTelemetry is one of the biggest projects of CNCF after Kubernetes. If you go and search on CNCF, a lot of people are contributing to OpenTelemetry and a lot of people are using OpenTelemetry in their application backends for observability purposes. Why OpenTelemetry? Because it created a unified standardized way for instrumentation. It created an easier correlation between different signals. It created a freedom to route data to multiple backends and observability platforms. Next was extensible processors and exporters. What it created an impact on observability is it reduced a lot of engineering efforts for monitoring SAT. It enabled a smarter pipeline for data processing. It formed the foundation of AI-driven observability platforms or systems. Data collector. Data collector is the core function or let's say core component of OpenTelemetry. It consists of three major things, that is receiver, processor, exporter. Receiver fetches the data from your application. Processors transform the data in which manner you need to feed to export. You need to feed to some SaaS backend. An exporter does that, expose the data to some of the SaaS platform like middleware, is a full stack cloud observability platform. And if you want to understand more on Hotel Collector, you can scan this code. There will be a blog on that, and it's detailed blog on Hotel Collector. Next, LLMs, there are a lot of anomalies that are detected by ML model. He also detect a lot of incident patterns being reported. We were not able to do that. And it also prioritizes an incident based on severity and impact prediction. LLM also help summarize incidents in human readable language. It also predict the potential future issues based on the historical patterns. If you see LLM also ready, then some of the major things are monitoring accuracy of the performance and also improving that, accident issue identification, and also health and reliability enhancement. ML and LLMs are transforming observability from passive monitoring to intelligent problem solving. So, what are the key data types in Observability 2.0? First are the events, then links profiles, dependencies, and eBPF memory. The eBPF changed a lot of things because it can fetch the data from the kernel level, all the request data, and it can also figure out a lot of things which hosts are open on, which packets are transformed, which routes, all the things are triggered by it, and all the things can be tracked from it. Three is the level of security. Comparing the features of Observability 2.0 with the traditional Observability. So I just wanted to have overview for you to better understand how the different things work. And the first thing is log collection. You'll just go on one of two examples. So log collection was manual. It was fragmented. By Observability 2.0 and created automatic pipelines, and it was centralized. In similar manner, different features have been changed. So observability cost explosion. So there are a lot of data, massive telemetry growth due to a lot of microservices, which needs huge storage, and it also costs a lot. Storing everything, every log, matrices, traces, even when much of it is irrelevant. Traditional observability models were not designed for cloud native scalability. Key cost drivers are high current matrices, in logs, and oversampling of traces. It resulted in increased infrastructure spend, slower query analysis performance, and noise, unnecessary noise, unmanaged noise. Then comes smarter data pipelines. So they help to reduce the noise. So in middleware, we have a feature called ingestion control pipeline that helps to exclude the unnecessary log from being stored to storage like S3 bucket or some external storage. So what are the key strategies? Some of the key strategies are dynamic sampling, filtering and deduplication, aggregation, edge processing. So these are some of the techniques and strategies that help to reduce the noise and also helps to reduce the cost. These are the benefits that I already covered. And what are the AI and the future already? So one of the major thing that I love over here is to consider a scenario where you have alert that your CPU is increased, CPU utilization more than 80%. And the thing is, you need to increase the storage or double down the CPU. So the alert would be you have 80% plus CPU utilization, and if you want to double down the CPU, you just click yes, the CPU should double it down. So it helps a lot of things. Next is AI assisted root cause analysis. AI can also help a lot of things to understand them better and to do things a lot of automated. And it also nowadays people are also using LLM observability to improve the performance of LLMs that they are using. This is a future observability trend in 2025. We have covered almost major of the themes: AI integration, open telemetry, AI workloads, automations, and all. So what are the outcomes from AI in future observability is faster recovery from incidents, greater reliability and resilience. Engineers focus on innovation instead of manual monitoring. If you want a detailed blog on Observability 2.0, you can scan this code. There is a detailed blog covering all the aspects on of Observability 2.0. You can connect with me on LinkedIn or any platform if you have some queries. Thank you for listening to me. Hope you have a great day ahead.